Good afternoon, everyone watching online here in the Philippines and abroad. Welcome to the Development Academy of the Philippines Public Sector Productivity Webinars. My name is Gerard Paul Calambro. I will be your moderator this afternoon. Let me introduce your co-moderator, Mr. Michael
Good
Sarabia. Good
afternoon,
afternoon.
everyone. Especially the topic about smart city. It actually gets me interesting when we talk about it because all of these technologies is possible for public sector to improve, increase their productivity.
All right, so let's start off.
Good afternoon. Welcome to our webinar on Fourth Industrial Revolution with emphasis on ISO 37120 for smart cities, also with robotics, artificial intelligence, and Internet of Things. My name is Dr. Ralph Sherwin A. Corpuz. I am a management consultant at the Development Academy of the Philippines, wherein I help various government agencies in the country in the establishment, maintenance, and improvement of their respective quality management systems. Today, we welcome you for another webinar on how to be able to improve our respective quality management systems. This is the topic outline. We'll be discussing introduction on 4IR, robotics overview, AI overview, IoT overview, ISO 37120 for smart cities, what is the roadmap that we have ahead for the integration of our respective quality management systems, and later on we'll have question and answer portion. So first off, let's review the ISO 9001 requirements. I think majority of you are core members of their respective QMS teams. As required in the standard 9001 clause 713 for infrastructure, organization shall determine, provide, and maintain infrastructure necessary for the operation of its processes and to achieve conformity of products and services. So the infrastructures mentioned in the standard include buildings and associated utilities, equipment, including hardware and software, transportation, and communication technology. Also stated in the standard is that we need to improve. Clause 10.1 in the standard states that the organization shall determine and select opportunities for improvement, any necessary actions to meet customer requirements, and to enhance customer satisfaction. Examples of continual improvement that we can do include correction and corrective actions, which are already in place in our QMS. Continual improvement as our best definition of quality. Breakthrough change, innovation, which is the main topic that we're going to discuss, and reorganization. We would like to emphasize about the significance of various innovative technologies on how we'd be able to use them toward our continuous improvement or continual improvement. So from these technologies, we can generate meaningful data which we can use for our decision makings. First off, I would like to introduce to you the Fourth Industrial Revolution, and let's talk about what are the significant technologies that we can use from this era. So as shown on the screen is an overview about the evolution of the Industrial Revolution. You will see here the four types of factories. The first one on the leftmost part still is the first factory. It uses still the mechanical way of doing work. So you see their gears and steam engines used as the primary drivers of their factory. The second one uses conveyor belts, and there's a production of automobiles. So you see here, essentially the manpower has been reduced. And the third one, you see here the rise of buildings. This is the third industrial revolution, wherein you see also robotic arms being used, and the outputs or the products produced are handheld devices. And the fourth one is the picture of the fourth industrial revolution. So you see there's an integration of drones. Also, you see the outputs are driving on their own. These automated cars or autonomous cars are already the byproducts of the fourth industrial revolution. As well as you see the train is communicating with the factory and other buildings or its surroundings. First off, let's have a brief overview or history about the evolution of the fourth industrial revolution. We have the first industrial revolution, or the 1IR. It started in Great Britain around 1760, and it has spread through the Europe and North America in the early 1800s. So the most significant contribution of the 1IR was the steam engine. It's been used in various industries at that time. Specifically, they introduced factories. In factories, the first three that proliferated was the textile industry, wherein they created a lot of clothing and other related equipment. Second industrial revolution, it has started sometime in 1800s. So it was marked by mass production. So from the factories in the first industrial revolution, they were optimized and used for the mass production of various equipment and technologies, such as automobiles. Also, during this time, new industries were introduced such as steel, oil, and electricity. Another major products of the second industrial revolution includes the light bulb, the telephone, and internal combustion engine, which are still used up to this time in our cars, other transportation means. The third industrial revolution, on the other hand, started sometime in the 1950s or the 20th century all the way to the 2000s. 3IR is also known as the digital revolution. The era has brought to us the invention of semiconductors, personal computers, cell phones, and the internet. So we owe it a lot from the third industrial revolution. Then here comes the fourth industrial revolution. Also known as the 4IR, is one of the recent most hot topics among academics, politicians, businessmen, sometime 2000s, even up to this present. So it's the era that builds and extends the impact of the 3IR in new and anticipated ways. So basically, we're still using the technologies of the third industrial revolution. The term 4IR actually was coined by the founder of the World Economic Forum, Professor Klaus Schwab, through his book called The Fourth Industrial Revolution, which was published in 2016. 4IR is also referred to as Industry 4.0, while others are referring it as the Smart City. So later on, we'll have to discuss further what's the difference between the two terms. Fourth Industrial Revolution, as defined by Schwab, is actually the advent of cyber physical systems where technologies are embedded in the daily lives of people, societies, and even within human bodies, thus blurring the lines between physical, digital, and biological spheres. Examples of integration of various technologies, such as prosthetic arms, prosthetic eyes, or also known as bionic eyes, in such a way that these devices or technologies are helping us to live longer and helping us to live normal lives. 4AR is also referred to as the age of intelligence, in which everything is rapidly becoming smart. Smart car, smartphone, smart TV, smart radio, smart everything. So when you say smart, basically it means it's connected and personalized. So from now on, we have Siri, we have the Apple Watch, wherein we can customize the contents in there. The issue with 4IR is that 4IR does not change what people are doing, but it changes people. So could you imagine yourself living without your cell phone? Have you realized that your screen time is actually more than 8 hours a day? And you cannot get rid of your activity of browsing over the internet or social media from time to time, just to check the updates and whatsoever. So that is how 4AR is already affecting us during these days. According to Schwab also, the 4AR can be characterized into three areas. One is in terms of impact. 4AR is disrupting almost every industry in every country, which herald the transformation of entire systems of production, management, and governance. So it is disrupting either in a positive or negative way. Positive way because it's opening new markets, new business or job opportunities for the young people and the skilled ones. So it's disrupting in a positive way. Disrupting also in a negative way, these technologies such as social media, cell phones are already disrupting or are interrupting business operations, which essentially derail operations and productivity of people. Another characteristics of 4IR is with respect to velocity. It is defined as the speed of current breakthroughs has no historical precedent, and technology is changing faster than ever. Technologies have never been imagined to be as successful as now. Later on, I'll be showing you some of the data or statistics wherein the adaptability of 4AR technologies have increased exponentially. So the adoption of various technologies are really something that we have to look at because they are unstoppable. Then we have the scope. In scope, technologies are merging more and more with human lives, and it involves an exponential rather than linear space. You will see that technologies are already embedded in our human bodies, from prosthetic heart, bionic arms, bionic legs. They're getting into our body, and time will come that maybe our organs are already pre-developed using 3D technologies or other future technologies, which we are looking forward to in the next few years. According to Schwab, this is another report from the World Economic Forum in 2019. I think this is from the Future of Jobs. No? They defined what are the top 10 4AR business trends that we have to look at. So here it's stated that sometime in 2022, we're expecting that there will be an increase in the adoption of new technology. So the new technologies that I'll be discussing later on will include some of the most exciting ones that we see in our day-to-day lives, whether in personal or in our house or at work or in the community. We have to expect also that there will be increasing availability of big data. Most research will focus more on big data, data analytics, and the like. So advances in mobile internet. Everyone is going mobile, independent, and we need mobile technologies. Artificial intelligence for us to analyze the data. Cloud technology in uploading certain contents via the internet. Also, there's a shift on economic growth. We will see that majority of the investments are now on 4AR. Of course, there's an expansion of affluence in developing economies because more and more countries are investing with 4AR. Then we could see that there will be an improvement on their economic or socio-political statuses. There will be expansion of education, whatever platforms and modalities are there. The one that we're doing now is actually a virtual education. So we have to look into this kind of trends in the future. Also, advances in new energy supplies and technologies such as green technologies and expansion of the middle classes, because the middle class will be the most essential workforce of the 4AR because they have the right education, right expertise, and the right mindset. The Industry 4.0 framework as defined by UNIDO 2020 include the following. So you see here it's divided into 4 areas such as new materials, biotechnologies, advanced digital production technologies, and nanotechnologies. At the core of this, if they're applied into a specific industry, then it's called a smart factory. The use of advanced manufacturing technologies are very essential for them to thrive into this ever-competitive environment or era. So some of the advanced digital production technologies that they have to invest with include industrial IOT, big data analytics, advanced robotics, artificial intelligence or machine learning, cloud computing, and additive manufacturing or 3D printing. The 4AR breakthrough technologies in the next few years, well, even up to these times, you see that advanced robotics are still there. AI, of course, is still there. We still see genetic engineering, IOT, 5G, which is new in the country, 3D or additive technology, sustainable or green energies, autonomous navigations using autonomous cars, and the blockchain technology using cryptocurrencies. So I would like to characterize the adaptability of 4AR technologies that we have just mentioned. Historically, it took like 75 years for the telephone to be adopted by 100 million users. Comparatively, with Instagram, it took only 2 years for it to reach 100 million users. And Pokemon Go, in interactive mobile application, took like 1 month to reach 100 million users. So you see, like the adoption of the 4AR technologies have increased exponentially. Another example of the demands of 4AR technologies in this particular example for 3D printer has also increased. From 2015 with approximately 200,000 demands, it has grown up to as much as 2.45 millions in 2020. Also, you would see here that 3D printed bone and bionic arms are massively used in various hospitals and in the world. So you see that they are now used for the development or the design of prosthetic legs, prosthetic hand, fingers, and a whole lot more. So they are now being used on various technologies to enhance human lives. You see here that there's an increase on 4AR related patents. Sometime in 1992, there were only like 200 patents to 5,250 patents in 2016. That is according to the European Patent Office in 2017. Majority of these patents came from the European Union, the US, Japan, Korea, China, Canada, and other countries who are contributing significantly to intellectual properties related to 4AR. The top 20 4AR patent applicants for 2016, according to the report of European Patent Office in 2017, include Samsung, LG, Sony, Nokia, Huawei, Qualcomm, BlackBerry, Philips, Intel, and the last but not the least is NEC. The top 10 key players of 4AR includes the US, Japan, Germany, China, Taiwan, France, Switzerland, Great Britain, Korea, South Korea, and the Netherlands. According to the report published by the World Economic Forum, it seems that the trends by 2022, the different technologies to be adopted include big data analytics, which will be 85%, app and web-enabled markets, 75%, Internet of Things, 75%, machine learning 73%, cloud computing 72%, digital trade 59%, augmented reality 58%, encryption 54%, and the last but not the least, aerial and underwater robots 19%. What are the outcomes of 4AR? So you see here a framework published by UNIDO 2020. Basically, 4AR are anticipated to be helpful on the UN Sustainable Development. So for inclusive sustainable industrial development, they are categorized into two, with the main goal of introducing new goods into the market. So essentially, it will create jobs and more income, emergence of new industries, environmental goods. Meanwhile, these new technologies will increase production and efficiency in terms of energy and material use, industrial competitiveness, and also linkages to supporting activities. So all of this together, if they are managed effectively, they can be contributory toward the inclusive and sustainable industrial development. What are the benefits for businesses? So using these technologies, also known as advanced digital production technologies, particularly for Industry 4.0 or the industries, they will yield new and better products. So if there are new and better products, you will see there are new solutions for marginalized groups, better quality and new business models, environmental goods. So on the right part, you would see the different results. Medical devices at affordable prices, personalized products and mass customization, new and database services, new pricing models. On the increase in production efficiency, you will see that energy efficiency and input optimization will also be improved. Operational cost reduction, improved capital utilization and employment of quality linkages to services. So you see that the benefits of 4AR to businesses, not just for businesses, also to the environment, are almost limitless. In terms of government, in the government sector, 4AR can also be beneficial in such a way that the conversion of bureaucratic processes into digital technologies will be very helpful. So you see it will provide, or it will yield digital skills. It will provide an enabling environment for digital skills, national innovation systems, policy and regulatory framework, and digital accelerators such as environmental, cultural, and behavioral aspects. We are looking forward about improving our government processes through the use of these technologies by capitalizing on digitalization. So another application of 4AR technologies in governments, they can use satellite data and artificial intelligence to detect illegal activities such as mining, traffic violations, deforestation, and manage freshwater resources. So we can use these technologies on how to be able to improve our monitoring capacities. Drones and machine learnings are used to increase crop yields and promote smart agriculture. So we can see that I think this one is used somewhere in Nueva Ecija. E-learning is making education cheaper and more accessible. So we've seen already the impact of e-learning during the COVID-19 pandemic, and we are looking forward to having more cutting-edge innovations in terms of the speed of data connections or the internet connections. We can use smart grids such as solar panels, wind turbines, etc. in bringing up electricity to underserved rural areas. So you see that they're now used in various communities in the country. Cloud computing technology can be used to improve public service delivery. So in this particular example, GSIS kiosks, they are placed in strategic locations so that it would be more accessible for government employees to check on their contributions. Also, IOTs can be used to improve customer experience, election process, transportation, etc. So you see the use of RFID technology connected to computer systems have been very useful in transportation and election and other applications. Digital technologies such as mobile apps are significant for disaster and emergency responses. So such as Batingao, developed by NDRRMC, has been very helpful during time of calamities. Aside from those benefits that we discussed, there are also some challenges that we have to take a look into with respect to 4AR. First challenge that we have to address is inequality. Some companies and governments, particularly the underprivileged or developing countries, are still struggling to keep up with the fast-paced technological change. So it's quite saddening that the 4AR may still not be felt among other countries who are still underdeveloped or still developing. The concept of 4AR from US may be different from the concept of maybe here in the Philippines because there is still a gap between the technologies used in both countries. Research shows that innovators, investors, and shareholders benefit the most from the innovation. So you see here on particular illustration provided by UBS in 2018, billionaires basically have driven almost 80% of the 40 main breakthrough innovation over the last 40 years. So you see only 20% has been used by the non-billionaires. The more innovation being introduced, billionaires are basically at the back end who are supporting this for profit and for whatever purposes that they have. But you see that most billionaires are controlling these new innovations in the world. This is a problem when the richest 1% of households already own nearly half of the world's wealth at 47%. So could you imagine, like, there's only like 1% of the total world population, yet they control as much as 47% of the wealth in the global markets. How much more if they do control the 4AR technologies of the future? So studies confirm that technologies like AI will eliminate some jobs and create demand for new skills that many workers don't have. For workers who did not have proper education, training, and of course, because they don't have the money to invest such, they will be most likely at the losing end because they may have hard time coping up with the 4AR jobs in the future. Experts warn that we are in a winner-takes-all economy where skilled workers are rewarded with high pay and the rest of workers are left out. So it's really crucial that nowadays we have to start upskilling these new technologies, new trends in such a way that we remain relevant. Another study published by Frey and Osborne in 2013, the following are the top 10 jobs that are most prone to automation. Telemarketers, 99%. Tax preparers, 99%. Insurance appraisers, auto damage appraisers, 98% should say. Umpires, referees, and other sport officials are 98%. Legal secretaries, 98%. Hosts and hostesses, 97%. Real estate brokers, farm labor contractors, secretaries and admin assistants, couriers and messengers. So these are among the top 10 most prone jobs for automation. So you have to watch out because you might be losing your job in the next few years. However, the following are the top 10 jobs who are least prone to automation. So you may be still existing in the next few years. Examples are mental health and substance abuse social workers, approximately 0.31%. Choreographers, physicians and surgeons, psychologists, human resource managers, computer system analysts, anthropologists and archaeologists, marine engineers and naval architects, sales managers, and chief executives. So basically, if you belong to these sample jobs, then you might still be existing in the next few years. In the 4IR, there are 3 jobs that are defined: stable jobs or stable roles, new roles, and redundant roles. Stable roles are the following: managing directors and chief executives, general and operations manager, software and application developers, analysts, data analysts, scientists, sales and marketing professionals. New roles are data analysts and scientists, AI machine learning specialists, general and operations managers, big data specialists, and a whole lot more. Redundant roles are the data entry clerks, accounting, bookkeeping, and payroll clerks, administrative and executive secretaries, assembly and factory workers, client information and customer service workers, and a whole lot more. According to the study of the World Economic Forum, the top 10 in-demand skills in comparison, the skills that are trending in 2022 include analytical thinking and innovation, active learning and learning strategies, creativity and originality, and initiativity. The skills that are going to decline in 2022 includes manual dexterity, endurance and precision, memory, verbal, auditory, and spatial abilities, management of financial material resources, technology installation and maintenance, reading, writing, math, and active listening, management of personnel, and a whole lot more. So you see what skills that we need to work out in the next few years. As projected by the World Economic Forum, stable, new, and redundant job roles, 2018, of course, 48%. The stable roles are still there, majority, followed by redundant roles and the new roles. However, in 2022, you would see that the new roles have already overtaken the redundant roles. New roles have come up to as much as 27%, and redundant roles are projected to be only at 21%. So you see that if you have a redundant skill or your job is considered as redundant, then you need to upskill. Another challenge that 4IR is facing is called security. Increasing inequality doesn't just affect our productivity and mental health, it also creates security concerns for both citizens and states. So in a hyper-connected world, when combined with rising inequality, security issues could lead to fragmentation, segregation, and social unrest. It's really crucial that we have to be careful about what we upload on the internet, on our emails, and our social media interactions. There's a saying goes that we have to think before we click. Drones, autonomous weapons, nanomaterials, biological and biochemical weapons, wearable devices, and distributed energy sources are among those technologies that should be regulated. So you see here, credit for Boston Dynamics, wherein they're showing an autonomous robots like kicking a person. So this one is almost like a threat to humanity. The concern on security when technologies are already overpowering people. Another challenge is privacy. Privacy is another issue as the 4IR turns every company into a tech company. The more that we generate the data from the application softwares that we're using, the more that we customize it, the more we put on information about us, personal information, educational background, social demographic profiles, etc., the more these companies or the more this data are risked for possible hacking. And this is what has happened to, let's say, Cambridge Analytica and Facebook, wherein they had been scrutinized for a possible data or privacy breach. So we have to be very careful on what we are uploading online. Now, in the Philippines, 4IR, it's something that's still new. We have to accept that. In fact, according to Kim, Tornio, and Yang in 2019, some nations have not yet reached the so-called Industrial Revolution. The question regarding 4IR is therefore not only on a question of what will take place in the future, but who exactly are included in this version of the future. So as I said earlier, maybe 4AR is the ideal phase now being enjoyed by most developed nations, such as in the US, maybe in Japan, in the UK. But these 4IR technologies are under process or still about to be adopted by the developing countries, particularly the third world countries. The third industrial revolution in the form of internet and globalization actually is still manifested in a different form in the developing world. So in fact, with the use of cheap offshore labor and outsourcing, the one that we have right now, we are really performing well in business process outsourcing. Maybe this is still our definition of 4AR. So this means that the Philippines will have a different experience of 4AR at least initially, according to Kim, Tornio, and Yang in 2019. So aside from these upcoming 4AR technologies, maybe our definition of 4AR is still a little bit primitive. Maybe we're still at the digitalization of our workplaces through the use of the third industrial revolution technologies. So we really have to be aware about the trends and do our best to invest on more infrastructures and technologies in such a way that we keep track of the trends and the future of our jobs. In this particular example, according to UNIDO 2020, Philippines belong to the late comers actually. We belong to the late 29 economies who are producing 4AR technologies. So we belong there. What is the definition of latecomers? So latecomers as innovators, we're into that. Economies with some patenting activity in advanced digital productions technologies. Economies with at least one regular patent family application in ADP technologies. So essentially, our patent and intellectual properties are still limited. So we really have to fast track our researches into this matter. The strategies to address skills needed by 2022, according to the World Economic Forum survey, most companies or organizations believe that we have to hire new permanent staff with skills relevant to new technologies. We also have to automate the work, retrain existing employees, 72%. Expect existing employees to pick up skills on the job. And last but not the least, strategic redundancies of staff who lack the skills to use new technologies. So likely, this is the projection, the World Economic Forum on what are the strategies that we'll be needing in the next few years. For us to upskill our competencies, these are the preferred partners according to the survey. Specialized departments within the firm or within the organization, professional services or consultancy services, industry associations, academic experts, international education institutions, local educational institutions, government programs, and labor unions. So it's for workforce demands for 4AR. In the Philippines, fortunately, 4AR is embedded in the PDP, Philippine Development Plan 2017 to 2022. 4AR is considered a priority in the PDP plan. Pillar number 3, it states that increasing growth potential, patuloy na pag-unlad by vigorously advancing science and technology and innovation, such as communication and utilization of research and development technologies, intellectual property culture, funding through PPPs, support for startups, human resource development funding, science and technology culture, and innovation hubs. The 4 priority research fields, according to Harmonized National Research and Development Agenda of the DOSD, are artificial intelligence and data science, big data analytics, Internet of Things, advanced electronics and communications, green technologies, etc. Also in PDP, pillar number 4, Foundations for Sustainable Development by Accelerating Infrastructure Development, they have the commitment to expand the development of ICT infrastructure and address the gaps in digital connectivity, continue to enhance the country's e-government system as a vital tool for good governance, and institute reforms in the policy and regulatory frameworks. In fact, this commitment of the national government is embedded in the national ICT plans, courtesy of the Department of Information and Communication Technology. So they have these programs called Establishing a Digital Economy through the establishments of the National ICT Ecosystem Framework, National Broadband Plan, Digital Terrestrial Television Broadcasting Migration Plan, National Cybersecurity Plan, E-Government Master Plan, Spectrum Roadmap, and National Alert Warning Systems Framework. We are hopeful that DICT will help us fast-track the establishment and improvement of various 4AR technologies in the Philippines. In DAP, and Development Academy of the Philippines initiatives, there are ongoing innovation projects, also completed ones, such as Syllabus Implementation Monitoring System, SSS Online Application System, EDSP Scholars Program. So these are basically the successful products designed and developed through the innovation projects of the Development Academy of the Philippines and the Center of Excellence in Public Sector Productivity. Another initiatives that DAP has include the Sparta. So this one is the latest partnership with Development Academy of the Philippines, with DOST, Analytics Association of the Philippines, and Course Bank. So they're offering as much as 30,000 scholarship slots for deserving students, whether they're professionals or still ongoing students, for them to become potential data associates, data stewards, data engineers, data scientists, data analysts, or analytics manager. So if we're looking at the profile of the Filipino workers, we see here that majority are young workers. The employees, Filipinos age profile, as you see here, majority are still young. 15 to 24 years old, they constitute 28%. You see that the majority of our workers are still young, followed by 22% of 25 to 34 years old. And then 35 to 44 is 18%, and 45 to 54 years old, 14%, and 55 to 64, 10%, and the retirees, or more than 65 years old, they're only like 9%. So you see that we have a very young and dynamic, vibrant workforce in the Philippines, so we have to take advantage of these strengths. In terms of the location of our workers, majority, of course, are land-based according to the employed OFW profile, because other than our local workforce, we also have our international or overseas workers. So majority of them are land-based, 78%, and those who are in sea, they are approximately 22%. That is according to estimate of POAA in 2016. Another highlight provided by the World Economic Forum states that the industry that will proliferate in the next few years, basically most investors are preferring Philippines as the destination of their technologies or their products, particularly in automotive and aerospace supply chain transport industries. The reason is talent availability. Same goes with aviation, travel, and tourism. It's more on talent availability. Consumer, global health and healthcare, so it's more on talent availability. For labor costs, they are more into the industries of chemistry, advanced materials and biotechnology, and financial services and investors. The emerging jobs that we have to look out in the Philippines include software and applications developers and analysts, sales and marketing professionals, managing directors and chief executives, data analysts and scientists, sales representatives, wholesale and manufacturing, technical and scientific products, general and operations manager, human resource specialists, financial investment advisors, assembly and factory workers, and database network professionals. According to technology adoption, well, according to the report by the World Economic Forum, user and entity big data analytics are still on the rise, 92%, Internet of Things, 83%, app and web-based markets, 81%, machine learning, 77%, cloud computing, 72%, augmented reality, 70%, digital trade, 65%, and a whole lot more. In the Philippines, average reskilling needs for us to cope up with the 4IR technologies, only 49%. They say that they don't need to reskill, so that's a plus point for the Philippines. For over 1 year, only 10%, 10% for 6 to 12 months, 3 to 6 months for 9%, 1 to 3 months, 12%, and less than 1 month, 10%. We have a positive outlook about the talent of our Filipino workers. The emerging skills that we have to look at: analytical thinking and innovation, active learning and learning strategies, creativity, originality and initiativity, technology decision and programming, critical thinking and analysis, complex problem solving, leadership and social influence, emotional intelligence, reasoning, problem solving and ideation, resilience and stress tolerance, and flexibility. So this time, let's move on with introduction on artificial intelligence. So let's define AI. AI, or artificial intelligence, was coined in the 1950s and still in use today. AI is defined as the capability to a machine to imitate intelligent human behavior. And AI is a computer or system designed to perceive its environment, understand its behaviors, and make decisions and take action. So basically, AI is like transferring over our senses into machines, so that these machines can think on their own. So AI systems rely on learning algorithms. So these are set of instructions. If you're good with coding, then or programming, then AI is a potential job for you, or an area for you to proliferate your skills, such as machine learning and deep learning techniques. So there are various techniques used in AI, along with large set of sensors data with well-defined representations of objective truth or model. So in AI, you need to utilize various tools, techniques for you to program, model certain frameworks, of course using different programming languages. And from here, you can come up with a model, then you design the set of instructions using different languages. You optimize or you utilize certain data from sensors or internet-based data. Okay, and then from here you could come up with a certain network and develop an application for the AI. AI gets more interesting when the machine cannot just imitate but match or even exceed human performance. So what's good with AI is that other than mimicking our human capabilities in terms of thinking and deciding, well, it's essentially very powerful and helpful if we're dealing with large amount of data. So that is basically the advantage of AI, because it will minimize human errors and optimize the resources, particularly on cost, operational costs, and labor costs. So AI gives us the opportunity to offload repetitive tasks, or even to get computers to do jobs more safely and efficiently than we can. AI is estimated to create $13 trillion in economic value worldwide by 2030, according to McKinsey forecast in 2018. While many organizations recognize the value and potential of AI, few are using it. Maybe whatever reasons, lack of skill, or maybe awareness, technical competence, and a whole lot more. Gartner's recent survey of 3,000 companies indicated that of 50% that are beginning to plan for AI, only 4% have actually implemented it. So there's basically a challenge on implementing AI. These are some of the reasons why we don't have to implement AI. There's a belief that to do AI, you need to be an expert in data science. Concerned that developing an AI system is time-consuming and expensive, lack of access to good quality, labeled data, the cost of complexities of integrating AI into existing algorithms and systems. So this is a representation about the AI family. In AI, there is called, of course, artificial intelligence is defined as the capability of a machine to imitate intelligent human behavior. A subset of AI is called machine learning, wherein we're going to train here a machine to learn a desired behavior through manual selection of features or data without predetermined equation as model. And deep learning is basically a technique of training a machine to automatically learn a desired behavior through multiple layers of neural networks. You need to prepare first the data, then you have to access data from sensors, audio, video signals, files, text, and databases. you analyze and explore data and pre-process them through normalization techniques or pre-processing techniques. So from here, you get this reliable data or features and you put them into an AI model using machine learning, deep learning, or natural language processing. Then you do the modeling and simulation. So from here, you come up with the system design through algorithm creation and further improvement. Then you integrate it with other algorithms. Then lastly, you deploy them for actual use through desktop or mobile apps, enterprise systems, embedded systems, and a whole lot more. A subset of AI is called machine learning. So it's a data analytic techniques that teaches computers to do what comes naturally to humans and animals. So you learn from experiences directly from data without relying on predetermined equation. Machine learning is synonymous with AI. It's just like you have to manually recognize the features and come up with a certain model and implement them for a certain application. When are we going to use ML? So we use machine learning if we would like to convert handwritten rules and equations, and it's hard to analyze this kind of data, such as handwriting, or maybe equations are too complicated, or maybe you would like to analyze facial expressions, speeches, audio, etc. So if you see, the type of data here is quite unstable. So ML is very useful for that purpose. The rules of tasks are constantly changing, as in fraud detection or transaction records. The nature of data keeps on changing, and the program needs to adapt, as in automated trading, energy demand forecasting, and a whole lot more. So we use ML to analyze certain uncertainties or fluctuations of data, and machine learning is very helpful for that. Machine learning can be categorized into two: unsupervised learning, wherein here we do grouping, and we interpret data based on the input. So the technique used here is called clustering. Another one is supervised learning. So here we develop predictive model based on the input and output data. So two techniques that we use here are classification, wherein we classify based on the predicted output, and regression through forecasting methods. In machine learning, some of the popular methodologies in classification include support vector machines, discriminant analysis, naive Bayes, nearest neighbors. In terms of regression, linear regression, support vector regression, ensemble methods, decision trees, and neural networks are the most popular ones. Unsupervised learning, for clustering, the most popular ones are k-means, fuzzy c-means, hierarchical, Gaussian mixture, neural networks, and hidden Markov model, and a whole lot more. So the typical workflow for machine learning is almost synonymous with AI. So you need to access and load the data, you pre-process the data, derive the features using pre-processed data, then train the model using the previous steps, you iterate to find the best model, and then later on you integrate with the application software or systems that you would like to apply to. Meanwhile, deep learning is another subset of machine learning, wherein here we do model loosely on neural pathways of the human brain. So we are training certain data so that they analyze the way a brain is thinking. So deep here means it refers to the multiple layers of between the input and output layers, wherein the algorithm automatically learns from what features are useful. So basically, it's learning on its own through different neurons or neural layers, wherein it analyzes input data and come up with a certain output. The popular networks or techniques used here are the convolutional neural networks, recurrent neural networks, or such as the long short-term neural network, or called LSTM. So one representation about machine learning versus deep learning here are the following. In this particular example, we are trying to categorize sample pictures and come up with their own category, whether they are car, truck, and bicycle. So in machine learning, there is a manual way of selecting the features. So we specify the nature of the features we would like to extract. So there's a manual extraction, and then here comes the classification. Meanwhile, in deep learning, you see here that we have to specify there are already learned features through the use of already pre-modeled networks, such as convolutional neural network. We need only to specify the architecture of the model because they're already predefined. Here, it will determine the accuracy to, let's say, 95%, 3%, or 2%. So from here, it could be more accurate because it has analyzed multiple layers of data or input data in the process. So some of the data sets being analyzed in machine learning or LSTM are numeric data, while for LSTM and convolutional neural network are based on time series and text data, while for convolutional neural networks, they are more on image data. So this is the type of data that we are working on in terms of machine learning and deep learning. So where do we see ML and or also deep learning? So you see that in computational finance, image processing, computational biology, energy production, automation, aerospace, and natural language processing. Sample AI applications in the Philippines, maybe you're familiar with the catch-all. So this one is automatically detecting apprehensions in the streets, violations in traffic, so whether it's coding or road accidents. So it's very helpful for MMDA and other regulatory agencies. So these are sample applications that you would like to use for you to explore AI or machine learning or deep learning. So MATLAB, TensorFlow, Keras, PyTorch, Scikit-learn, and Orange are among the most popular ones. Sample AI application that you would like to consider is like you may want to integrate AI with your existing quality management systems wherein you would like to automatically detect or identify the appropriate clause for a specific audit finding by just reading on the text. So you put on the text on the finding, and then the AI system will automatically categorize what is the clause for that finding. So in that aspect, we can come up with a certain model using, let's say, Orange in this particular example, wherein text-based findings are converted into numerical data and essentially modeled through neural networks and come up with a predictive model. And then when you feed in here a test sample data, it can predict the actual clause of the standard. Another important technology in the 4IR is the robotics. Robotics is defined as a multidisciplinary area of engineering and science involving the fields of mechanical, electrical, computer science, and other engineering-based fields. So it refers to the science of design, construction, operation, implementation of robots, as well as computer systems for control, feedback, and information processing. The term robot was actually derived from the Czech word by Karel Čapek in 1921, which means a worker or a servant. So basically, you see here Asimo. A robot is a reprogrammable multifunction, a manipulator designed to move materials, parts, tools, or specialized devices through various program motions for performance of variety of tasks. So it can be physical robots or it can be a virtual software bot. The different types of robots are the following: robot manipulator, legged robot, wheeled robot, self-driving cars, unmanned aerial vehicle, or autonomous underwater vehicles. So the uses of robots can be into the industry, education, security, agriculture, tourism, retail, healthcare, infrastructure. So you see robotics is everywhere. There's basically what we call ethics in AI, wherein we have to control robots. Whenever we design robots, we have to make sure that they abide on the laws of robotics. Law 0 says that a robot may not injure humanity or through inaction, allow humanity to come to harm. Law 1, first law, a robot may not injure a human being or through inaction allow human being able to come to harm unless this would violate a higher order law. Law number 2, a robot must obey orders given to its human beings, except for such orders would conflict with a higher order law. And law number 3, a robot must protect its own existence as long as such protection does not conflict with a higher order law. So basically, this ethics of AI applied to robotics is just to put a control that whenever we design robots, we have to always uplift humanity and we always have to look on the welfare and safety of humanity. Here, the evolution of the robot from the first generation to the 5th generation, as they are used in industrial robot for manufacturing, automation, service robot for private services, public services. They are categorized as intelligent, interactive, and mobile. Then the 3rd generation or ubiquitous robots, you use services, they are networked, they're calm, they're seamless. Then 4th generation, we have the genetic robot or artificial species. They're now adaptive, developmental, and genome-based. And the 5th generation, which the ones that we have right now, these are the humanoid robots, bio-robots, or another term. They are biocompatible, enabled, biocontrolled, and bio-embedded. So a brief history about robotics. 1954, we have the Unimate. It was designed by George Devol, who was the father of robotics. It was used to automate the manufacture of TV picture tubes. So you see that a sample diagram. In 1957, USSR launched the Sputnik 1, which was the first artificial satellite in the world. Then in 1977-78, the Puma, or Programmable Universal Machine for Assembly robot, was developed by General Motors. It was used for industrial operations. And then in 1980s, many robots have been developed, such as the Adept Scanner robot, WAM robot arm by Barrett Technology, Helpmate service robot used in hospitals in the US, WL123I was the first bike walking robot developed by Kayo Corp. In 1990s to the present, we have the P series by Honda, which is the ancestors of Asimo, the Mars Pathfinder autonomous robot used in Mars by NASA. There's also Robotuna by David Barrett in 1996. This is used for underwater exploration. The Mindstorms by Lego in 1998, which were used for educational purposes. A space station remote manipulator system, they're used for the International Space Station. Mars Curiosity rover, which is just recently launched in 2003. The Atlas by Boston Dynamics, one of the most advanced humanoid robots. And the almost human-like robot called Sophia by Hanson Robotics in 2016. So it's a very intelligent one. You can converse with Sophia and interact spontaneously. The key components in robotics implementation are the following. You need to address dynamic system modeling, feedback control, and computer programming. So these are sample platforms that you can use toward the integration of software and hardware, such as MATLAB, MPLAB, or Arduino. Key components, you need to have controllers such as microcontrollers and microprocessors, which are the brain of the robot. You also need to have sensors such as vision, camera, proximity force, tilt, sound, temperature, distance, pressure, light, GPS, digital magnetic compass, and gyroscope as the sensing technologies or tools for your robot. You need also to have actuators. Examples are synchronous stepper AC servo DC servo motors, which are used to actuate so that your robots will move. So key components that we use in robotics: system peripherals also, such as storage, memory, digital controllers, power converters, and a whole lot more. These are the additional devices or tools that you can use on improving the performance of your robot. So this is the framework of robot. Basically, you need to have sensors and system peripherals as inputs. Going into the controllers, you need to do programming and some manipulations or techniques for you to enhance the AI competencies of your robot. Then your actuators should be controlled by your robot or the controllers in such a way that they will execute some physical activities. The advantages of robots are the following. You will improve production because you will minimize human interaction, improve quality and precision, reduce waste because there's a little bit error now, increase safety, promotion of humans to supervisory tasks, potentially high ROI because of more savings. Robots are used for jobs that are dangerous for humans, like exploration to Mars, in various applications like in Japan, wherein there's a extensive radioactive activities, in underwater exploration and military activities. Robots are also used for repetitive jobs that are boring, stressful, or labor-intensive for humans. So you see here some of the robots used for car manufacturing. The bots are the software robots, no? They answer inquiries. Maybe you could find them in messengers. Another one is a banana tossing robot, wherein it's used for maybe food preparation. And then the other one is an automatic welder. So all of these are quite menial for people, so they are very helpful. Another applications are robots are now being used for medical surgeries. Another one for recreation, solving rubrics. Another one, they're used for firefighting application, and they are used for warehouse. I think this one is for Amazon. Then they're also used for menial tasks that humans do not want to do. So maybe, Asimo is serving as conductor. Robots being used in agriculture, robot sweeping over dust and unwanted waste. You see another robot cleaning up toilets. So these are essentially making robots very useful for a human. Now, the disadvantages, according to a report by Oracle and Future of Workplace 2019, by 2030, up to 800 million workers around the world could be replaced by machines. The fear of rampaging robots isn't just restricted to jobs. So AI, Elon Musk has also said that AI is a fundamental risk to the existence of civilization, wherein AI is essentially controlling robots. So he suggested that governments and entities should regulate the use of AI. This illustration shows the different skills wherein human and machine have shared altogether. So you see that the reasoning and decision making, machine will take as much as 28% in 2022, and then coordinating and developing 29%. Meanwhile, information and data processing, robots may contribute to as much as 62%. So the more percentage that these robots will contribute, then the more chance that humans will be replaced. Also, if you will invest in robots, it will require big initial investment and maintenance costs. Your ROI is not guaranteed. Employees should be technically trained, which entails another financial cost. Another one is there are robotic trends that we have to be familiar with. There's the International Federation of Robotics reported that in 2016, the average global robot density is about 74 industrial robots installed per 10,000 employees across the manufacturing industry. So the most automated countries in the world are Korea, Singapore, Japan, and Germany. Also, the implementation of AI technology, including robots, is expected to add as much as 15.7 trillion to the global economy by 2030. So you see, global robots are also very helpful. Robots can bring complementary skills to the workplace. 75 millions of jobs may be lost due to automation by 2022. Another 133 million additional new roles will be created. So 82% of workers believe that robot managers are better at certain tasks such as maintaining work schedules and providing unbiased information than their human counterparts. So you see, more people are trusting robots nowadays. Almost 64% of workers worldwide, specifically in China and India, they trust robot more than their human manager. So you see, like, you find robots more trustworthy than your colleagues or your bosses. In the Philippines, if we'll compare with other ASEAN countries, the Philippines is among the lowest in the region for automation adoption in terms of robots. So there are 3 industrial robots installed per 10,000 employees in 2016. So that's like way behind Singapore, which uses 488 robots and 45 robots in Thailand. Fortunately, in the Philippines, we have, of course, 48% of work in the Philippines, or equivalent to 18.2 million jobs, have been automated. The good thing is that while the redundant tasks are automated, robotics can create more jobs, and Filipino workers should upgrade their skills and retrain. Schools should revise curricula to include robotics and automation. So we'd like to thank DTI, DepEd, Commission on Higher Education, and TESDA for improving their curricula in such a way that we remain relevant. So there are Philippine Robotics Olympiad in the Philippines, wherein our students are participating yearly as organized by DOST. Drones are also used in surveillance in Marawi, and lately we have the drones being highlighted during the closing ceremonies at the SEA Games. Drones are also used in smart farming in Muñoz, Nueva Ecija. They're also used in various malls in the country. So these are some of the industrial partners that we have to look at because they're providers of software and hardware resources for robotics technologies. Internet of Things is another hot topic in 4IR. So IoT is defined as connectivity and internetwork of electronic devices, also known as connected or smart devices. So this one is basically a network of different electromechanical devices put together into one system. So it was coined by Kevin Ashton of Procter & Gamble in 1999, originally referred as Internet for Things. IoT enables objects to be monitored and controlled remotely. So in this particular example, you see a phone that would able to like control a water meter, a natural gas meter, electricity meter through, of course, the Microsoft Azure, for example, wherein it's connected to the internet. As long as you have the internet, then you can control almost everything. So if you heard the word smart, smartphone, smart computer, smart city, smart everything, it's because it's all interconnected together into one functional system. So in principle, IoT has 3-layer architecture called the application layer, the network layer, and the perception layer. Well, first off, it starts with the perception layer, wherein we use here different technologies such as RFID, camera, sensors, a whole lot more for them to catch certain data and put into a network layer for further processing. So through the use of wireless or wired networks such as optical fiber, 3G, 4G, 5G, LTE, etc., they are transported into middlewares wherein they are used as meaningful data in the analysis and further embedding on these application software, whether they're smartphone applications, e-health applications, or power management applications as used by consumers. That's basically the end of the layer architecture of IoT. So in this particular example, you see here the application of IoT in a certain agricultural field wherein it's deployed. There's the remote user, cell phones monitoring the status of his crops. Basically, there's database and gateway node, and all these are interconnected through the internet. So you see, it's a very helpful application of IoT, particularly in agriculture. IoT is very popular in consumer perspective. So you have the Apple Home, you have the Google Home, you have here a sample of smart home setup, wherein through the use of, let's say, a microcontroller, you can interconnect them all together through the net. You can control the electric gate, you can control your email alerts, you can control your air conditioner, you can control the lights, the fan, the door lock, etc. And all of these all together are connected through the internet, and you could use your Android smartphone, and you being the user, you could use the tablet or maybe your Apple Watch for you to remotely control your home. IoT are also used in medical devices. So like this one is a remote health monitoring system wherein it uses, let's say, for example, a wearable heart monitor. You can check if your heartbeat or your blood pressure is changing or increasing. Infrastructure IoTs are also everywhere, like you see in smart parking. If you go to various malls, you could see which particular slot is open, which is red, which is green. And then in electronic toll collection system, you use RFID. You also use this for logistic management, autonomous vehicle, which is the most promising application of AI. Here, it's extensively autonomous. You have to learn a lot of things like vehicle to everything communication technology, infrastructure, and pedestrian communications. In industrial IoT, as it's applied in the industry, you are controlling every aspect of the production, from manufacturing plant to global facility insight, customer site, global operations, and different departments. You could control it by just using cell phone or the internet. Industrial IoT is also applicable in various smart grids wherein you can control the distribution of energy into the various areas of the community through the smart grid powered by the IoT, wherein the energy sources are coming from wind energy, solar energy, nuclear power plant energy, thermal power plant energy. Sample IoT researches in HEIs are the following: solar-powered real-time monitoring buoy alert system. They're used to detect red tide in the Manila Bay or Bacoor Bay area. Another one is IoT-based pulmonary monitoring system. So here it detects if the customer is prone for pulmonary infections. Pros and cons of IoT. Pros, of course, data access. It would be easier for you to access everything. Communication will be seamless. Monitoring will be easier because just a click away. Automation is enhanced. Cost effectiveness is also ensured. Meanwhile, the cons are the following: privacy and security. Since everything is connected together, you can easily see things out. So some of the private or confidential information may be leaked. Complexity may be quite hard. You need a lot of invest in various technologies, infrastructures, including competence and skills of your talents, of your employees. Safety is also another factor. Reduce jobs because, of course, we are cross-cutting manpower. And dependability, we don't know if the one that we're installing is actually dependable. IoT is still a work in progress. In terms of the trends, we see that IoT is very promising, that it's projected to impact as much as 86% on the global GDP, as projected by McKinsey Global Institute in 2018. This is where IoT is very popular in the world. IoT is also envisioned to form part on the attainment of the Sustainable Development Goals of the United Nations, specifically on Goal 9, Goal 11, Goal 7, and 3, 12, and it's looking forward to improving. Well, we have to focus on research, particularly on zero hunger, quality education, and life below water. The big IoT industries in the Philippines include, well, of course, the DICT, which is the regulatory arm, DOSTP shared through its hashtag emergent. Some of the providers for hardware and software materials, Raspberry, Cisco analog devices, Arduino, ON, Microchip, and IEEE. So this time, let's talk about how we're going to integrate all these technologies together and be beneficial for the community. With the 4IR, we have reviewed the evolution of 4IR. What are the significant technologies that we have to look into? Now, here comes a smart city. A smart city is defined as a city in a system of systems with unique history and a set of specific environmental and societal contexts. So according to ISO IAC JTC1 Smart Cities 2014, it's composed on various contexts. Environmental context, is it flat? Is it hilly? City history or characteristics. Also, it has city governance. It has city purposes, the city actors, the activities, communities, facilities and buildings, infrastructures, soft infrastructures, technical systems, city functions and services areas, scale, and societal context. So all of these together form Part D city model. Why is it crucial for us to understand our cities? According to, let's say, the report from United Nations, by 2050, the world population is expected to reach nearly 10 billion people in the world. That's way too big. 80% is the amount of people living in the cities by 2050. So you see, 20% will only be living in the rural areas. Surface occupied by today's cities on the Earth's surface is already 2%. We get lots of people living in the city, yet it's only 2% of the total geographic areas. Amount of energy consumed by actual cities is 60%. And then the amount of waste and greenhouse gas emissions produced in the cities is 70%. So you see the impact of cities and of course the population and the people living there. It's very crucial. So we have to really manage these cities very well. There are a lot of pressing issues in cities such as public transport and facilities, water supply, sanitation, food security, energy consumption, peace and order, climate change, healthcare issues, carbon and energy emission, overpopulation, and unemployment. Well, of course, with the guidance of United Nations, UN Sustainable Development Goals, it's crucial that communities, for them to thrive and become smart enough and resilient enough, then they have to consider all these factors. So here comes this smart city term. For us to become smart city, we have to be familiar about certain terminologies. Smart city is defined as a city that increases the pace at which it controls social, economic, and environmental sustainability outcomes and responds to challenges such as climate change, rapid population growth, and political and economic instability by fundamentally improving how it engages society. So earlier, we discussed the context of smart city. If you would able to, let's say, manage it very well, a particular city, understand its context, and overcome these issues altogether, then you can possibly establish a smart city. It requires you to apply collaborative leadership methods, work across disciplines and city systems, and you have to use data or information and modern technologies to deliver better services and quality of life without unfair disadvantage, degradation of the natural environment. So basically, it's a holistic management approach on how to be able to establish a smart city by making use of good leadership and optimizing resources in a fair way. So smart city is basically defined into 4 layers, whether in terms of purpose, in terms of common meaning, or in terms of characteristics. That is according to Daglio and Welch et al., as discussed at the IoT Forum Smart Cities in 2015. A smart city is defined in 3 domains. One is through its purpose, common meaning, and characteristics, according to Daglio and Welch at ITU Forum on Sustainable Cities 2015. So in terms of purpose, a smart city is accelerated on improvement towards sustainability and resilience. Sustainability is the destination, smartness is the accelerator. Characteristics that define smart city are the following. It has to be people-centric, it has to be well-led and governed, it has to be inclusive and open to all people and new ideas, transparent in communications and operations, secure in respect of personal information, supported by integrated services and infrastructure, and proactive in learning and developing. According to ISO IEC-JTC1 on smart cities in 2014, a smart city is composed of 7 layers. From layer 1 to layer 7, it talks about the abstraction of the applicability of various technologies from the design or conceptualization all the way to development and all the way toward the user interface, how it is perceived by the community or by the consumer or by the people. At the bottom of the layer are the infrastructure resources. Smart cities should invest on roads, trains, buses, buildings, parks, etc. And the next layer, 6th layer, is the acquisition, wherein sensors, cameras, GPS, meters, smartphones should be installed in such a way that various data or information will be effectively captured and further analyzed. The next layer is called the interconnection. So we have to invest also in networking facilities, DSL, Zigbee, Wi-Fi, 4G LTE, 5G as crucial interconnecting points toward the establishment of smart city systems. Next is the integration, the 4th layer. It's a combination of the sensor data and other city data through geographical information, economic or population data. Then we have the analytics, which is a very crucial way of analyzing data through the use of AI, machine learning, or let's say deep learning, predictive analytics, and data mining techniques. Then we have the apps or the software layer, wherein service-oriented architecture or cloud computing and computation and storage are included. And the last but not the least, which is is the very first layer close to the needs of the people. Of course, they need safety services, health education, transportation, water, electricity, and e-government services. Smart cities should be able to maximize all their resources in order to establish these layers from infrastructure all the way to services. Now, on this slide, we highlighted the green, which means that these are the areas wherein 4AR technologies can be optimized in such a way, realizing the establishment of smart city. However, it's not always as perfect whenever we establish a smart city. We have challenges ahead. Unfortunately, there are no guidelines on conformity indicators. Well, at least in the data from on the year 2014. That time, data are often collected at the national level and not local. There are no standard definitions of what to measure, no standard methodologies on how to measure. There are limited, no baseline data for cities, no data and knowledge sharing mechanism across cities. Small cities or the towns in rural areas would have a hard time coping up with their city counterparts because the limited data where they can benchmark with. So these are among the challenges that have to be overcome by smart city standards. Well, ISO has defined that need to plan now to be able to deliver the resources and services needed to ensure their population survive and thrive. So ISO standards are very meaningful because they represent the international consensus on the best practices in a wide range of areas that contribute to making a city functional and fulfill the UN Sustainable Development Goals to end poverty, protect this planet, and ensure prosperity for all. So basically, these are the reasons why we need to standardize data for the attainment of smart cities. First is to determine entry points for investments in city markets and make informed decisions through data analysis. Of course, we also have to benchmark investments and monitor progress to evaluate the impact of infrastructure projects on the sustainability and efficiency of the city. We also need to build smart and sustainable cities to evaluate the investment in comparative perspective across cities nationally and globally. And lastly, to strengthen the effectiveness of city governance. Basically, standards laid down by ISO that we can use in the establishment of our smart cities. So we have ISO 37122 for resilient cities indicators, 37121 for smart city indicators, and 37120 for sustainable development indicators. So altogether, we can use this as guide in establishing the specific key performance indicators and how we'll be able to define a smart city. Of course, there are supporting standards that we can also utilize with in our efforts, such as ISO 37101 deals about strategic leadership approaches on establishing sustainable development. ISO 37106, which details out how do we manage process approach of managing the smart city or the smart operating model. And the last but not the least, the baseline of the standard suites, ISO or TS 37151, which is very technical. Here, there are smart city community infrastructure that we can look into and benchmark what are the best practices in the world. Just having an overview about 37101 2016, basically, it is a standard managers or leaders or local government officials can use in setting up their objectives to define the strategy for sustainable development. Here in ISO 37120, they have to define the objectives of why they have to be certified, such as responsible resource use, preserving the environment, and improving the well-being of citizens. And here, they need to identify the issues in their community or in their city, such as governance, empowerment, education, health, and mobility. So these are the sample purpose of sustainability, which they can put on their objectives in terms of attractiveness, preservation, resilience, responsible resource use, social cohesion, and well-being. Another feature of the ISO 37101 is that it can develop a strategy for a manager or a leader or a government official in creating an action plan, allocating responsibilities, and measuring performance, and including continual improvement for that particular community. So these are the contents of 37101 2016, the issues that need to be addressed in terms of governance, education, innovation, health and care, culture, community identity, etc., etc. So who can use the ISO 37101? Anyone in the world, any community, whether it's a small or big city or just a town in a rural area, it doesn't prescribe a specific requirement in as far as size, the type of that particular organization or government. So it is applicable to almost any type of government, local or national levels. These are some of the screenshots of ISO 37101 as published by ISO. Then, this is the PDCA model wherein it's almost similar with ISO 9001. It has the context, it has leadership, it has planning, it has support, operation, evaluation, and improvement. However, the output here is more on how do we define sustainable and resilient and smart community. Another standard that's also useful in establishment of smart cities is the ISO 37106. If the 37101 is more focused on strategic or leadership perspective, this one is more onto the operational level. So here, standard gives guidelines on how to develop an open, collaborative, citizen-centric, and digitally enabled operating model. So it focuses on enabling processes with the use of technology and data coupled by organizational change. So before, this is the operating model of various communities or cities in their conduct of daily activities or delivery of services. So this result to being unconnected, they are not customers focused, it's closed system, and basically it's stuck up from against improvement. With the proposal of ISO 37106, there is a need to revitalize or to reinvent on how do we operationalize government, whether at local or national level. So here, city data are unlocked and individual silos. There's a logical separation of data, service and customer delivery layers, internally driven innovation, and ability to drive citywide change at a very significant change. There are also different layers that needed to be addressed: technology infrastructure, data, integrated citywide governance, services, and community delivery, which benefit altogether the citizen or the business. The key features of ISO 37106 operating model are the following. We are focusing on relentless and tangible outcomes. We come up with cross-silo governance, citizen-centric service transformation, and we do unleash the actual city data, which is very essential on our improvement. So this is the high-level structure of ISO 37106, which has the delivery principles in terms of visionary, citizen-centric, digital, open, and collaborative. It has the cross-city delivery process in terms of strategy management and citizen-centric service management. It has also digital and physical resource management, which altogether result into well-being, attractiveness, social cohesion, benefit realization strategy, preservation and improvement, responsible resources, and resilience. Another one is the ISO 37151 as of 2015. So this is smart community infrastructures, principles, and requirements for performance metrics. So we could use this in the definition, identification, optimization, harmonization of community infrastructure performance metrics, including in smartness, interoperability, synergy, resilience, safety, security of community infrastructures. The infrastructures that we need to establish are not limited to energy, water, transportation, waste, and ICT. Basically, the principles of ISO 37151 are applicable to communities of any size. And also, it depends on the characteristics of each community. So basically, it's applicable to any organization type. Also, along with these standards, organizations or local governments can also take advantage of industry-specific ISO standards such as ISO 17742 for energy efficiency and savings calculations, ISO 5001, ISO 5006, urban mobility, 39001 for road traffic safety, ISO 39002 for good practices on implementing community safety management. Another standards, ISO 24510, guidelines for the assessment for the improvement of services to users with respect to drinking water and wastewater services, 24511 for wastewater utilities, 24512 for drinking water utilities, 20325 guidelines for stormwater management in urban areas, and 24516 for guidelines for management of assets of water supply, 25518 crisis management of water utilities. ISO IEC 27001 information security management system, ISO 38500, 30182, ISO 21972, ISO 27550, 27551. In terms of infrastructure, we can take advantage of ISO TS 37151, ISO TR 37152 on respect to smart community infrastructures principles and common frameworks for development. Another is on security and resilience, ISO 22313 for societal security, 22327 for security and resilience, 22395 for security and resilience, community resilience. Another for health and well-being, we have Iowa 18 for framework for integrated community-based lifelong health and care services in Asian societies, ISO IAC Guide 71 in accessibility and standard, ISO 45001 for occupational health and safety management systems. We have the ISO 37120 2018. So it's also known as Sustainable Cities and Communities Indicators for City Services and Quality of Life. This standard basically has 17 themes called the economy, education, energy, environment, finance, fire and emergency response, governance, health, recreation, safety, shelter, solid waste, telecommunication and innovation, transportation, urban planning, wastewater, water sanitation. The 7 themes are basically composed of specific indicators that define smart cities. They are generated from ISO 37122 and indicators for resilient cities as they are generated from ISO 37123. So these are the specific indicators being a smart city, education, economy, water and sanitation, wastewater, transportation, and urban planning, while these are the themes for resilient cities in terms of shelter, safety, recreation, health, governance, fire and emergency response, and finance. How to become a certified smart city? So there are basically 3 types of indicator. Core indicator, another one is supporting indicator, and the other one is a profile indicator. So when you say core, it demonstrates performance in delivery of city services and quality of life. While supporting, basically, they demonstrate performance in the delivery of city services and quality of life. And profile are indicators that are recommended to provide basic statistics and background information to help cities determine which cities are interest for peers for comparison. In each indicator, there are criteria that needed to be addressed or needed to be defined in terms of completeness, technology neutral, simplicity, validity, verifiable, and availability. So these are basically the specific criteria that will be measured for us for a specific city. So let's say, for instance, in terms of economy. So in terms of economy, a particular city may be evaluated in terms of city's unemployment. So example, one indicator is that a city may be assessed in terms of the number of working age primary residents who are not paid in employment, or self-employment numerator divided by the total number of force, or the denominator, multiplied by 100%. And then here, are the sample support indicators in terms of percentage of persons in full-time employment, youth employment rate, etc., etc. And the profile here may be used as reference by other city governments or other organizations: average household income, annual inflation rate, and average city product per capita. Another one is education, for instance. The core indicator is percentage of female school, age population enrolled in schools, percentage of students completing secondary education, survival rate, primary education student ratio. And the support are percentage of school-age population, number of higher education degrees per 100,000 population. These are the issues, for example, education and capability building, attractiveness, youth, unemployment rate 5.4, 6.6 is number of higher education degrees, social cohesion 5.4, 6.1, percentage of female school 6.2, percentage of students completing primary education survival rate. How do we map with ISO 37101? There are also issues on well-being 5.4, 6.1, 6.2. So you see, ISO 37101 is complementary with ISO 37120. It's really crucial that we have to understand these standards in such a way that we will be guided thoroughly. So how is it being mapped with the UN SDG? So in the USDG, basically it has goal 1, wherein it has the goal to end poverty in all its forms everywhere. So using the ISO 37120, we can somehow meet these goals by identifying the percentage of city population living below international poverty line, percentage of city population living below the national poverty line. Meanwhile, goal 2, for example, end hunger, achieve food security, improve nutrition, and promote sustainable agriculture. We could use these indicators: 20.1 total urban agricultural area, amount of food produced locally, percentage of city population that is overweight or obese, and a whole lot more. We are grateful that there are also organizations wherein we can work with or support services and where we can obtain more information about being certified. The World Council on City Data was established to help into this process. So you can get into their website at dataforcities.org. Here, some of the cities have already requested for certification, and they're subjected for evaluation based on the established parameters or criteria the one that we talk about, the core, the support, and then the profile. So from here, they're evaluated such a way that such data can also be used by other organizations or other cities for them to improve their performance and become smart cities on their own. The data for smart cities, they are standardized in such a way that they generate knowledge, and they are used for analytics, and essentially they're used for innovation purposes. So there are various level of awards being given by WCCD. If you get a point of 30 to 45 specifically on core indicators, then you are called aspirational. Meanwhile, if you get points 46 core plus 0 to 13 on supporting indicators, then you are considered as a bronze certified. If you get points 60 to 75, specifically 46 on core and 14 to 29 points on supporting, then you are called silver certified. While if you get 46 and 30 to 44 supporting, then you are considered gold certified. And if you get 91 to 100, specifically 46 on core and 45 to 54 points on support, then you're considered a platinum certified organization or community or city. So ISO 37120 is just the beginning. So in here, if you go over the standard on ISO 37120, specifically the indicators on resilient cities taken over from ISO 37122 and complemented with ISO 37123 with 50 indicators. The WCCD, being the pioneer for the establishment of smart cities worldwide, have already identified pilot cities for this purpose. We have Los Angeles, Guadalajara, Bogota, Buenos Aires, Toronto, Boston, London, Barcelona, Macla, and a whole lot more. In the Philippines, we have Makati City has been certified as one of the smart cities in the world. If you get into their website, you can see some of the interesting facts about that particular city. So here, for example, how clean is my city? So here, 99.91%. Percentage of city population with regular solid waste collection. This is the case of Bogota, Colombia, who has been tagged as an aspirational city in 2014. Another one is how sustainable is my city? Maybe evaluated in terms of dwelling density per square kilometer. In Buenos Aires, Argentina, it's 6,102 is the dwelling density and has been awarded as platinum certified as of 2015. How safe is my city? So here, violent crime rate per 100,000 population. 27.33 is the percentage accomplishment for Dubai in UAE, and they've been awarded as platinum certified in 2015. Another one is how do people move around my city? So here, my percentage of commuters using a travel mode to work other than a personal vehicle in London is rated at 74%. So that's in London, United Kingdom. So here you could see that London is also awarded as platinum certified by WCCD. Another one is how politically inclusive is my city? So according to the evaluation conducted by WCCD, it's measured in terms of voter participation in last municipal election as a percentage of eligible voters. So that makes Makati City in the Philippines with 68.07% for that particular criteria, and being awarded as platinum certified in 2015. So how would we be able to inject all together these 4IR technologies and manage potentially a smart city? So here you can see how we can use the different technologies that we have discussed earlier about the use of robotics, use of artificial intelligence, using machine learning or deep learning techniques, maybe using IoT, on how we'd be able to leverage the performance of smart cities. Guided by ISO 37120, then we can capture this data that have been laid down in these different infrastructures. Then we store them into a safe and reliable database or servers. Then we analyze them using various techniques or algorithms. Then we conduct prediction models in such a way that we would able to publish this data for evidence-based decision-making purposes. But unfortunately, there are also challenges that we face in the establishment of smart cities. One is public trust. Another one is we have poor planning, financial resources or constraints. How do we customize the data for that so that it will tailor fit on the context of that particular government. Digital disruption, of course, is another disadvantage, and cybersecurity. So what are the opportunities that we can take a look into? First off, being a leader in a government, a local government, or possibly regional, local, or even at national level, we can come up with a vision such as set a long-term and short-term objective. We also need to have strategy, but it has to be realistic. No, we have to prioritize certain key areas and then adopt the standards that we discussed earlier. Of course, the leadership, we have to commit and support the 4IR journey, and we have to secure funding if we have issues on budgetary constraints. Implementation, we need to engage the full participation of relevant interested parties. That's important. We have to forge innovative and creative partnerships with governments, industry, academia, and other stakeholders. Design and implement inclusive strategies and programs for skills, retraining, and upgrading. Also, we need to invest in providing cutting-edge hard and soft infrastructure. Government should provide open data to citizens and invest in research and development to enhance smart city capabilities. We also need to encourage the citizens to participate in designing apps with their contents, including the crowdsourcing activities. We have to promote green technologies or green competitions and provide incentive programs. Share the essentials of 4IR through corporate social responsibility and related activities. Now, for workers, there is an unquestionable need for lifelong learning, so we need to invest on our own talents, trainings, and the likes. The question is that we are now ISO certified in our own agency. So, in what way are we able to contribute to the attainment of smart city? So, basically, it's being a smart city is not just the task of one government agency, for instance. It's not just the task of the local government, or it's not just the task of, let's say, the national government, but it's basically a holistic and interconnected effort. If you are an ISO 9001 certified already, maybe we can think of something that we can contribute toward the attainment of smart city in the community wherein your agency belongs to. So if we are ISO certified, for example, we can come up with memorandum of agreement or terms of reference with the community that we belong to, or maybe we can adopt a community where we can help in establishing resiliency or smartness. So with that, first off, we need to conduct strategic, financial, and development planning. So, of course, it has to be spearheaded by the local government in such a way that there is a direction that this particular project will go through. We need to identify the core group, whether it's internal for that particular agency or that particular LGU. We need to enhance the competence of our personnel, so we need to leverage our training and seminars, particularly on the use of new technologies such as the ones mentioned, like AI, machine learning, deep learning, and a whole lot more. Forging of linkage partnerships with potential funding from the national and local governments, that's very crucial. We need to improve our resources in compliance with various international standards. So I've mentioned that these different standards that we can look into. We have the ISO 37120, ISO 37101, and ISO 37106. We also need to deploy these 4AR technologies. They will help on the realization of ISO 37120 20 visions for a smart city. These 4AR technologies have been proven to be effective and at the same time worthy for the establishment of resilient smart cities. So let's deploy them as soon as we have them. Then we need to improve also our research and innovation capabilities, because without this we were not able to move ahead on the competition. Then before that, we need to conduct initial gap assessment. We can request for consultancy services with experts such as DAP for us to be guided on how to be able to be Smart City certified. Then we're going to prepare all the certification activities such as documentation, implementation, auditing, and implementation guidance on the ISO 37120. And of course, the end result of this journey, we will be Smart City certified. Now, again, the Smart City here is defined as the community where we belong to. Maybe it could be in a form of local government, or maybe a higher level of local government at the national, at the provincial, or maybe regional level, in such a way that we would able to help, particularly those who are in the rural areas, for them to improve and establish policies, programs, and projects that are beneficial for the welfare of the community and for the citizens in there. So in a summary, I'd like to emphasize that 4IR is here already, and tomorrow is now. So, like we have discussed also, AI, machine learning, deep learning can make 4IR technologies smart through various techniques like algorithms and models. So we have to be familiar with these terminologies. Also, a robot is quite an ambitious leap to mimic human capabilities. So I think we don't have yet the capability to get into this, but we can possibly start first with modular learning approach in order for us to understand robotics further. Maybe we have to start with automation, at least in our very own organizations or agencies. Also, IoT is powerful in a way that it can merge the 4IR technologies into a single network of cyber-physical systems. So we've seen examples of how IoT controls almost everything from hardware to software. So it's crucial that we have to invest also in this technology. 4IR as applied in manufacturing is called Industry 4.0, while 4IR as applied to establish sustainable communities is called Smart City. So somehow they're interchangeable and they have almost similar meanings, but they are basically applied to different perspectives. Industry 4.0 is part of a smart city. So essentially, it's a collaborative effort of the different government agencies, private sectors, private and public individuals, in a local government or regional or national government, all together helping one another and establishing the specific indicators, methodologies, and strategies of becoming a resilient and smart city. We can use the QMS as the springboard in initiating improvement by, of course, capitalizing on improvement in terms of infrastructure and other breakthrough technologies. So we need infrastructure such as hardware, software, facilities is the heart of the smart city. You have to take note of that. Hence, government organizations should leverage funding and investment in these technologies. I know that we have limited capacities in terms of budgets. We can venture into, let's say, partnership or memorandum of agreement with funding agencies and other private institutions who can help us in the process. Smart City is the outcome of 4IR, where national and local governments, communities, industries, residents, and other stakeholders are happily living together with the use of cutting-edge technologies that enhance sustainable life. So how I wish we get into this future wherein we don't just enjoy the goodness of life, but also we share it with other people, we share it with the environment, and it makes our lives more comfortable, more convenient, and more livable than ever. You have to refer to a number of standards for you to be guided in the attainment of Smart City certification. So there are various standards that we have discussed, but essentially ISO 37120 will be enough for you to start over. Every stakeholder should work as a team and foster unity and cooperation. Of course, nothing is impossible if we work all together. So being you as a standalone government agency, or maybe as a private citizen, or maybe you belong on the local government as an official or as a citizen, we have to work hand in hand for us to be able to attain a smart city through the use of 4AR technologies. So that ends my presentation. Thank you so much for listening. We appreciate your time and efforts, and we look forward to meeting you for more webinars and expert consultations in the future.
Why don't we start on actually reading some of their questions? I read some interesting questions, and I'm sure that they would also be interested about Dr. Ralph's answer about those questions.
Let's start off with Antonio Ahmad, and he is asking, he watched the Netflix documentary, if the fourth industrial revolution is in the hands of big and powerful industries that tend to manipulate ideas and chooses what ideas could be thought about by the people, what regulatory measures need to be implemented to arrest the bad effects of manipulation?
Well, in my presentation earlier, I've shown that Elon Musk and some other companies or tech companies in the Silicon Valley has already signified their request to regulate AI, right? So they have proposed that we need to regulate facial recognition because it's like a threat to our security and also in our privacy. We have heard about TikTok being banned in the US and other countries. Also, there are some proposals of banning genetic engineering wherein we can modify the genes of our future babies. Also, nanomaterials wherein it can alter some of the materials used for the production of, let's say, spy materials or some cameras that are hidden in our clothing. Well, essentially, our goal here is we need to control AI so that we have to foster ethics and also intellectual property and human rights should be upheld. We can suggest to have, like, say, a regulatory body or a competent authority who will regulate AI actually in the world. It's not yet existing, but there are already ongoing proposal for that. Maybe an equivalent UN body or an international body that will regulate production of AI, particularly in tech companies. Maybe we can come up with some AI ethics in every organization. Ethics committee who will, let's say, come up with certain policies that are tailor-fit for particular company or organization, that whenever they produce an AI-based technology or application or software or maybe hardware or robotics related, then it has to go through with ethics review. And they have to check if there are certain biases in the design and conceptualization of that particular AI product. But you know what? Yeah, it's in the Philippines. It's quite a different story. Yeah, in the Philippines, we know that we are still starting up. In fact, in the presentation earlier, we have said that we might still be at the third generation or third industrial revolution, wherein we may be still lagging behind from, let's say, the US or Japan or Germany. So maybe instead of controlling, let's first foster it, right? So I think in our own ways, we know that we still lack the capacities to implement AI, robotics, or let's say smart city in full blast. Well, there are organizations or national agencies who are already working on it for, let's say, the artificial intelligence roadmap. We have agencies like the DTI, Department of Agriculture, DOST, DICT, I think CHED is also included, NEDA, who form part on the, who were included in the PDP, the Philippine Development Plan. So they come up with a certain roadmap on, let's say, coming up with memoranda of understanding or agreement in, let's say, establishing certain AI hubs in different regions, so that maybe certain investors or maybe state universities or higher education institutions will participate into research and development activities. So I think that's what we have to, like, focus on right now. We need first to foster, because we are not yet there. Here we do encourage, let's say, the participation also of the private industries, business associations or organizations to help us in the process. So it's basically a win-win scenario, right? You know, like, we need to enhance, maybe support first maybe the state universities on their capacities and research and development, because we believe that we have intelligent and young and dynamic and talented Filipino students out there. You have seen earlier the statistics on our manpower. We have very young but vibrant workforce. So maybe let's work into that for the meantime, or at least we're starting over. So DEP, along with DOST, has developed or designed the Sparta. So maybe it's about time that we promote this one. We have still, like, available slots, so you could enroll for data scientists or data analysts, or those are the tracks that you can enroll. We encourage that. So you have to, like, know more about AI. How would you able to grasp the basics of it, and how would you able to eventually deploy it in your respective organizations? Another one is maybe we could provide incentive programs. This one may be for the local government or maybe for the national government. Incentive programs maybe for startup companies, because they're still basically starting up. So maybe we could provide assistance for them. Also with big companies who are investing here in the Philippines, like Microsoft or Google, or because we have cheap labor and our manpower is also at par with the best in the world. So maybe we could provide incentives program for them so that they will invest more in the Philippines, and essentially later on they can help on the establishment of smart cities. Basically, it's not just more on the control, but maybe let's foster as of the moment. So that's my take onto that.
Thank you very much, Dr. Ralph. So we have another question here from Mr. Christian Salazar from LRTA. So he was asking about, can an organization that did not experience system automation proceed directly to implementing an AI system, what are the crucial, unique steps in fusing AI technology in an organization?
Okay, so earlier I've shown you some of the example methodologies or techniques on how to implement AI. I mentioned that there is a machine learning, there is a supervised and unsupervised learning. There are various techniques like classification, clustering, and then if you would analyze them in multiple layers, then here comes deep learning. Maybe these are relatively new, but if you will go back with history, these are basically based on statistics. So if you have prior background in statistics like multiple regression or linear regression, then maybe you could analyze this altogether and come up with a certain program and implement it that way. So maybe it's just about reassessing what do we know, and maybe, yeah, understanding first what AI is, and you would know about the history of AI, and you'll realize that essentially it's just statistics, and it's you're applying it with computer programming and some computer skills and some kind of manipulation, so you have to optimize based on whatever computer you're using or the language that you're using. I think it's more on realizing what you can do, because you will realize that maybe you have the capacity to do simple programming, linear regression. Maybe from there you could start over for clustering, for classification applications and regressions and all that. So the question is that, can you jump automatically with AI implementation? I think yes. So it's just a matter of maybe investing on your competence or say training skills that are related to AI.
All right, sir. Thank you for that answer. So we have another question. It's more related to the mining industry. Miss Catherine Pagapatan is asking, is AI already used in monitoring illegal mining activities? And do you think mining investments will also increase given the demand for more resources to support new technologies? What's your opinion on that, sir?
DNR, as a regulatory body, I have not seen yet an official statement that they are already monitoring or surveying illegal activities through AI. Although maybe they are doing it manually or the traditional methods of surveying or surveillance methods, but I haven't seen an official statement yet that AI is already implemented in the process. However, we don't know. We believe on the capacities of the research and development initiatives of our students in the HEI or SUCs. I think they already have come up with certain prototypes or maybe proposals in their research or thesis on, let's say, utilizing certain satellite images on capturing where these particular illegal miners are dwelling. I think I've just read one research from a foreigner's perspective. They have, let's say, studied the illegal mining of black sand somewhere in Luzon, in Subic area, and they use satellite images and sonar to capture these illegal activities. So there are research works on which are being done in the universities, and they're also published online. So I think there is already an ongoing efforts of integrating AI on improving the mining activities in the country. Now, as far as the demand on mining, well, you've seen that the trend now is going sustainability. So in smart cities, so we need to address these issues. So if mining is one of the contributory of these issues, let's say environmental degradation, then I think it's the other way around. So mining industries should be thinking about certain activities that or processes or procedures that will help them more sustainable, rather than them like deliberately using these raw materials for their industry. Maybe they have to invest on other technologies that will enhance their operation, and maybe use green technologies such as solar or, let's say, wind energy and other renewable energies that will power their existing systems. So I don't think that there will be a greater demand for the mining industry as of the moment, but it's on the other way around, that the mining industry should tone down because more and more new materials are discovered, such as, like, say, instead of using, let's say, metals or, let's say, gold for, let's say, production of semiconductors, they're using sand. So, you know, sand is basically a silicon dioxide, and you just have to remove oxygen from it, and you could come up with a silicon. And silicon in electronics is just the foundation of everything. And, you know, like from sand, you could use it for your own productions. So what I'm saying is that maybe the future of mining industry may not be as profitable as we see it in the next few years, because we are going sustainable. We're going green. So in fact, the mining industry should think about how would be able to come up with certain procedures or policies or processes in order for them to remain relevant and catch up with the 4AR technologies.
Thank you very much, sir. I think we have a question that's related to education sector. So it's a question from Rufino Placido Jr. So what will be the future of artificial intelligence in education sector? Especially, I think this is relevant because we have been utilizing the internet during this COVID season for the students. What do you think about its application on the education sector? And maybe trying to answer a bit as well about its relevance at this time of pandemic, sir.
You know, modules are now popular. So teachers are like investing so much time on developing these modules. It's quite saddening that, of course, in the state universities or maybe in public schools, they're still doing the manual way. But you know what? Using AI still is it's limitless. You know, it's just based on your imagination. How would you able to like exploit this technology and make it more meaningful for the education? What I'm looking at is maybe yeah, we can enhance what are the existing tools that are available right now. Let's say Google Forms. You can actually use it for, let's say, for examination purposes. So maybe you can tweak certain script in there and come up with a more personalized way of presenting your lessons. Other than, let's say, Google Suites, maybe you could make use of certain LMS, learning management systems like Microsoft MS Teams and other learning modules, and then coming up with simple tweaks, like say using Python or a little bit of C language or C# programming, and you can connect them all together. I'm looking at certain interconnection of different tools all together and generating certain data or capturing certain data from the responses of the students. So maybe it's more on personalized learning. So maybe later on AI can come up with a certain modules that will maybe evaluate the capability of the student based on previous responses, maybe in terms of personality trait, maybe in terms of intellectual capacity or something like that. So it would be a more personalized learning approach. Another one, what I'm seeing is that maybe because of the new normal that we cannot go physically and to let's say going out for let's say plant visit, then virtual or augmented reality is in demand. More and more companies are offering this kind of technology, wherein it's just more in the imagination of you going there. I'm also anticipating that more and more technologies will be educating the teachers. So more like Siri type technology, wherein it will give or it will provide a teacher much more meaningful data, like a Wikipedia on the go or Wiki on the go, wherein a teacher can just do Control F and find the information from the internet. So this is what I'm looking at as the future trend of AI in the education sector. So it would be more interactive and spontaneous at the same time.
All right, thank you, sir, for that wonderful answer. And we have questions from Ms. Holita and Ms. Lisa Magana. We will combine their questions. If you will gauge the percentage, where is the Philippines in the fourth industrial revolution? And being a developing country, we are facing many challenges in terms of technology, not to mention cultural and political issues. Having this scenario, how can we catch up with these new trends?
Yeah, I think earlier I said that the Philippines is way behind our first world counterpart like the US and Japan. They are considered as the advanced manufacturers. We are actually considered as latecomers to the 4IR. We do produce certain semiconductor materials through our plants in Laguna and Cavite and other areas. We thank them for that because they represent at least a portion of our producer status. So, well, I think we are more into the manpower side on how we're able to like provide talents, young talents, like say providing skills on data science or analytics and all that. So I think that's more of the opportunity that we can capitalize with. Yeah, I think if the question is that if we are ready to get into there, I think we're not yet ready. So it's basically a collaborative effort between the national government through the different agencies that I mentioned earlier. 7 agencies who are working for the artificial intelligence roadmap with the support, of course, of the Digong or the new president. Maybe we could come up with certain incentive programs and how would we able to encourage investors, particularly tech companies, to invest and adopt a certain community for them to develop these smart cities. So essentially coming up with a more sustainable environment or community we could work on to or live with.
There's another question about the transportation system from John Michael Ramos. So he was asking about what is the stand of the national government regarding intelligent transport system. Will this be applicable in our existing road network? So maybe this may help ease traffic in major roads.
Intelligent transport system is basically a holistic technology management system. There are a lot of aspects into that. If we will inject, let's say, AI, I think I've shown earlier CATCHA. It's a research output from De La Salle. It's in coordination with DOST and MNDA. So they came up with an AI system that can detect certain vehicular a violation or maybe vehicular accident on the road. So that's one aspect into that. So if you're asking, is it on process or is it on the go? I think it's yes. So MMDA, DOST are into this aspect. But that's just part of the intelligent mobility or transportation system. There are more to go, like the investment infrastructure, the industrial IoT, and how would we be able to come up with a certain centralized data system that will analyze traffic, that will analyze congestion of people or pedestrians coming over into a certain area. So I think that the presentation earlier on IoT, maybe that's from where we can start over. And I think MMDA, the ICT, and DOST are on the go now, and they have different plans on their own.
Yeah, we are very hopeful that will happen as well. So another question from Ms. Regina Regidor. To have a workable system and technology, we need the energy and power to have connection and also the security of consumer and vice versa. So what must the Philippine legislature must do to further upscale our system and technology in terms of connectivity, power, and security? So what laws or policies that the Philippine Congress should do, sir? What's your opinion?
Yeah, I think I mentioned earlier that we are still in the early phases of the 4IR. And we are still on process of institutionalizing or formally introducing the AI in the Philippines. So with the 7 agencies that I mentioned, Department of Agriculture, NEDA, CHED, DepEd, DICT, DOST, DTI, they are working onto this. I think they can propose certain policy, let's say adopting the cybercrime law, maybe another AI policy on the utilization of data from users. Well, we have, let's say, CIC is in place in terms of protecting, let's say, credit information of the Filipinos. We have that. We have IPO for protecting intellectual properties and all that. Maybe we could come up with the same strategy. A certain national government agency will regulate certain researches or certain guidelines on how to be able to utilize this input data coming up from customers whenever they transact with the government, or maybe they transact with companies, and maybe a competent authority that will manage this data and put them in a secure server and have it audited by competent authority, or maybe by COA or another regulatory body for that purpose. So I think it's a collaborative effort between different agencies, and we're looking forward that this will happen in the future.
All right. Thank you very much, sir. So I think we'll be answering one more question. Mr. James Jr. Colongan has an insight of his own, and he said that these emerging technologies are going to change the world more than anything in the history of mankind. So more than electricity. So data is the lifeblood of all organizations. Data-driven decisions increasingly make the difference between keeping up with competition or falling further behind. So he has a question though about what can you say about the adoption of the Philippines on these technologies? Is it about financial capacity or the awareness that matters?
It's both, but we don't. I think we don't have yet that enough financial capacities to support or to initialize AI in the workplace, for example, and then moving forward to, let's say, in the local community or into the national level, capacitating the different agencies or even the private companies. So I think it's more an awareness that we need to invest more, awareness that we have the capacity, we have the skill to easily adopt, let's say, computer skills, programming skills, modeling skills, and we have this universities, state universities, or even the public schools, they have this enthusiasm to like learn more, because it's just a way, because we view education as the only ticket that we have for us to become successful in the future. So maybe we have to intensify this curriculum or curricula in these schools, in the college, high school or college, in such a way that we have to inject 4IR into it. And essentially, it's a long-term process on improving the competence and the skills of our students, and then they will be graduating eventually, and they'll contribute for nation building. So I think it's just the best way that we can do right now. Awareness that we have the skill, that we have the strength on our manpower, the very young and dynamic and vibrant manpower, and we are looking forward for support from the local government, from the national government, from the industry, and other funding agencies in the world to help us on this process.
All right, so we had a very interesting discussion this afternoon. I would like to thank everyone who participated in the chat box. So on behalf of the Academy, I would like to thank everyone for watching, and we hope that you have learned a lot from this afternoon session.
I'm sure that our participants have learned a lot. I actually also get excited when we talk about this stuff, and I'm sure that institutions such as the DAP, the DICT, and other technology-related government institutions is also aiming to capacitate the different government sectors about technology and fourth industrial revolution. So the Philippine government and Philippine public sector institutions, I'm sure, is very willing to adopt these technologies. I'm very well excited on these different innovations that each of us can do.
So again, my name is Gerard Calambro.
My name is Michael Sarabia.
My name is Sherwin Corpuz. Thank you for your time.
And we hope to see you again tomorrow on our third session. So again, see you again tomorrow.
Thank you very much.